Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to all of you in the physics online lecture series for 10th class. Today in this video, we are going to solve the numericals of chapter number 1. Numerical 1. The time period of a simple pendulum is 2 seconds. What will be its length on Earth? What will be its length on Moon? If the gravitational acceleration on Moon is 6 times less as compared to the gravitational acceleration on Earth, whereas the value of gravitational acceleration on Earth is 10 meter per second square. As we know that for time period we have the relation t is equal to 2 pi under root L over g. So first of all we will rearrange the formula by taking square and getting the value of length. So the formula will be rearranged as L is equal to t square into gravitational acceleration divided by 4 pi square. So from here, by putting the value of gravitational acceleration of Earth, we will get the length of the simple pendulum on Earth, which is 1.02 meters. So similarly, the same process will be done to find the length of the simple pendulum on the surface of the Moon. So we will rearrange the formula accordingly, which will be L is equal to t square into gravitational acceleration of Moon divided by 4 pi square, and finally we will get the answer 0.17 meters. Numerical 2. A pendulum of length 0.99 meter is taken to the Moon by an astronaut. The period of the pendulum is 4.9 seconds. What is the value of g on the surface of the Moon? This is again the same questions as we have done before, but here instead of finding the length, we are going to find the gravitational acceleration on Moon. So again we will use the formula of time period of simple pendulum, which is t is equal to 2 pi under root L over g, and by rearranging we will get the value of gravitational acceleration of Moon, which is 1.63 meter per second square. Numerical 3. Find the time periods of a simple pendulum of 1 meter length placed on Earth and on Moon. The value of g on the surface of Moon is 1 by 6th of its value on Earth, where gravitational acceleration on Earth is 10 meter per second square. So again we have to use the formula, that is t is equal to 2 pi under root L over g, and by putting values we are simply going to find the time period. Numerical 4. A simple pendulum completes one vibration in 2 seconds. Calculates its length when gravitational acceleration is 10 meter per second square. So we have the given data and we just have to find the length. So already we have found this formula in our previous numericals by simply rearranging and taking squares on the both side of the formula of time period for simple pendulum. So finally for length we get the form of the equation as length is equal to time square multiplied by gravitational acceleration whole divided by 4 pi square. So by putting values we will get the length as 1.02 meters. Numerical 5. If 100 waves pass through a point of a medium in 20 seconds, what is the frequency and the time period of the wave? If its wavelength is 6 centimeter, calculate the wave speed. As we know that frequency and time period are reciprocal to each other, and we also know that wavelength, frequency and speed of the wave are related with each other with the formula, that is v is equal to f lambda. So first of all we know that frequency is the number of waves passing through a point in a unit time. So if there are 100 waves and they're passing in 20 seconds, then the frequency will be f is equal to number of waves divided by time, which is 100 divided by 20. So frequency will be f is equal to 5 hertz, and time period is its reciprocal, so the time period will be t is equal to 0.2 seconds. By simply putting these values in the relation of speed of the wave is v is equal to f lambda, so the wave speed will be 0.3 meter per second. Numerical 6. A wooden bar vibrating into the water surface in a ripple tank has a frequency of 12 Hz. The resulting wave has a wavelength of 3 cm. What is the speed of the wave? So as we know that the relation for wave speed is v is equal to f lambda, and the wavelength is in centimeters. So first of all we have to convert it into system international unit, that is meter. So we will divide 3 by 100 because 1 meter is equal to 100 centimeters, so we will get 0.03 meter, and by putting this value in the formula we will get the wave speed as 0.36 meter per second. Numerical 7. Transverse wave produced on a spring has a frequency of 190 Hz and travels along the length of the spring of 90 meter in 0.5 second. So we have to find three things. Number one, what is the period of the wave? Number two, what is the speed of the wave? Number three, what is the wavelength of the wave? So as we know that time period and frequency are reciprocal to each other, so simply the time period will be division of frequency by 1, so we will get time period as 0.005 seconds. In our previous studies we also come across the formula, which is distance formula, s is equal to vt. So simply by rearranging that formula we will get the value of v, which is 180 meter per second, and finally to find the wavelength we will get the equation in the form lambda is equal to v by f, and simply by putting the value of wave speed and frequency we will get the wavelength as 0.95 meters. Numerical 8. Water waves in a shallow dish are 6 cm long. At one point the water moves up and down at a rate of 4.8 oscillations per second. Find the speed of the water waves and find the period of the water waves. So this is the simple numerical as we had already done before. We just have to solve this numerical on the basis of the formulas that we had already learned. So here in this numerical we are making use of the formula v is equal to f lambda and t is equal to 1 by f. Both of these formulas are already studied in our coursework and already have been used in the previous numericals. Numerical 9. At one end of a ripple tank 80 cm across, a 5 Hz vibrator produces waves whose wavelength is 40 mm. Find the time the waves need to cross the tank. So first of all we have to take the values into the SI form, which is actually SI unit. So we have to convert the millimeter into meters and similarly centimeters into meters as well. So after changing these values we have to make use of the formulas of v is equal to f lambda and the distance formula, and definitely the formula for time, which is t is equal to v by d. So in the previous numerical you just have to ignore the mistake of the intermixing of v and t. So it is actually t is equal to the answer, and the unit is seconds. So numerical 10, what is the wavelength of the radio waves transmitted by an FM station at 90 megahertz, where 1 mega is equal to 10 raised to power 6 and speed of radio wave is 3 multiplied by 10 raised to power 8 meter per second. So simply here we just know the values, and the value of mega is also given, which is 10 raised to power 6. So first of all, by changing the frequency into its SI units and then putting these values in the formula V is equal to F lambda, after rearranging, because here we have to find the wavelength, which is lambda, so lambda is equal to V by F, and simply by putting values we get the answer as 3.33 meters. So this is all about today's lecture, and the whole lecture is your assignment.